Hello, and today we're going to talk about Paris-Erdogan equation. And I looked that up on YouTube, and I didn't find any explicitly made explanations, and there is no proper example solvings. So I decided to do it myself, and I hope you understand. So the purest form of the equation is dA over dN equals to C times delta K over M. And M and C, these are dependents. These depend on the material, so they will probably be given. And delta K is K max minus K min. So what are those things? What is K? We're going to talk about that articulately in an explicit way. And first of all, I'm going to give this two terms, KIC and KT. What are those? KT is stress concentration factor, KIC is fracture toughness. And stress concentration factor, KT, equals sigma maximum over sigma normal, average sigma, average stress. And this also equals to 2 times A over R. So what? A is crack length and R is fillet radius. So if you look at a crack, if you make a little circle right there, and this is R, this is fillet radius, and length of the crack is A. So KT, stress concentration factor, depends on the crack length, and also it depends on the fillet radius. This is not the only equation about stress concentration factor. We have a second equation, KT equals Y times sigma. This is, well, you should say G, sigma G, times pi times A, square root of that. So Y is, well, in some books it says F, in some books it says Y. This is correction factor. This is correction factor. And it depends on the shape of the material. So this is also probably be given. This is sigma G is stress amplitude, which is maximum strength minus minimum strength over 2. We have also mean stress, which is maximum stress plus minimum stress over 2. And we're going to talk about that later on. A, as I said, that part, A is crack length, KT is stress concentration factor, and KIC, fracture toughness, is a specific value of stress concentration factor. Okay? So we know what are those K's are, what are those things. And dA over dN, this is called growth rate. And, creep graphs, this is an example of it. The derivative of this part, this is second state. We also call it steady state. When we want to find this rupture time, TR, we don't actually look at those parts. We actually only look at steady state, because those parts, first and the last parts, they happen so fast. So we don't use that. We don't look. We don't add that into the equation. So we explain the parts, and the quick example is, let's read that a high strength steel in the figure 3, which is this, which has a fracture toughness of 80 megapascal times square root of meters, is subjected to an alternating stress varying from minus 900 megapascal compression to plus 900 megapascal tension. It is survived for 10 to the 5th cycles before failure occurs. Assume that F equals 1 for the steel, C equals 1.62 times 10 to the minus 12, and n equals 3.2. So we're going to calculate the size of a surface crack required for failure to occur. I already made the solving. This is, you use the equation that I talked about, and as I said, fracture toughness is just a specific value of the stress concentration factor. I talked about that here. So you find that, this applied stress or stress amplitude is maximum minus minimum over 2. So 900 minus 900 over 2 equals 900. So from there, AC equals to 2.515 times 10 to the minus 3rd meters, and this is 2.515 millimeters. And then you use Paris-Erdogan equation, that part, to, the A over the N. If you take the integral of it, you will take this. You'll take this into the equation. So delta A over delta N, which is given, circle is 10 to the 5th. You find delta A to, this one, and this is a end at the end minus A0, and to find the largest initial surface crack size that will permit this to happen, initial, so this is delta A, this is the last one, the rupture one. Why I used this part, why I used that part, and we know the AC, this is the last value, last crack length, and we know this is the delta. So if we the first crack length plus this delta A equals AC. So from that part, we find the largest initial surface crack size that will permit this to happen. From that part, we will find the answer. Thank you.